Hello friends, I hope you are doing great. Welcome back to my YouTube channel Void Loop Bytes and Automation. In this video, we will learn how to interface a micro SD card with STM32F411 Nucleo board. We will see the hardware connections, configure SPI in STM32 CubeMX and understand how to read and write data to the SD card using FAT file system. This tutorial is very useful for data logging, IoT projects and embedded storage applications. So without wasting any time, let us get started. To get started, we only need two main components, the STM32F411 Nucleo board and a micro SD card module. We will be using the SPI protocol for communication. This requires 4 data line plus power. For the wiring, first connect the VCC pin of SD card module to 5V pin on Nucleo board and connect the ground pin to GND. Now for the SPI signal, connect the clock pin to PA5 and MISO pin to PA6 and the MOSI pin to PA7. Finally, our chip select pin, which we will use to control the communication, will be connected to PB6 on Nucleo board. So this is our schematic diagram. Now let us move on firmware development. Open the STM32 CubeIDE. We will create new project. So go to File and click on New, then STM32 project. OK. Click on board selector and search Nucleo-F411RE and select this. Click over here and next. Type here project name. Then click on finish. Click on yes. OK. This is the pin output and configuration. We are not going to use this LED. So do right click over here and reset state. Do same for the PC 13 pin. OK. Now click on clock configuration. Set the H clock 16 MHz. OK. Now go to again pin out and configuration. Go to the connectivity and SPI. Select here full duplex master. Select the prescaler 2 to get the 8 Mbps speed. It is on you. You can select as per your speed requirement. Now select the PB6 pin as a GPIO output for chip select. Now go to the middleware and software. Click on FatFS and check the user defined. OK. Now go to the set defines and change the use long file name. Enable with static working buffer on BSS. OK. And change the max SS 4096. Then click on save. Yes. Yes. OK, this is the code. Now let us do some modification in main.c file. Include here some header files. OK. Now let us define __IO put char function to use printf with UART2. Now copy this function and paste here to declare it. OK. Now go to the code directory and add FatFS_sd.h file into the inc folder and add the FatFS_sd.c file into the src folder. OK. Now go to the FatFS and target folder. Then open user_disk.io.c file. Let us do some changes in this file. OK, you can see this is FatFS_sd.c file and this is FatFS_sd.h file. Here all commands, chip select pin and SPI handle are defined. Now let us go to the main.c file and add the SD card test function. Copy it and paste here to declare. Let us call the function to perform the SD card test. Okay. Now open the dock light to see the print. Now click on debug and select here board related comport and baud rate. Okay. Click on debugger and check the ST link and click on scan. Now apply, then OK. Now click here to start this serial. Let us do one step over, step by step. Let us go to inside of SD card test function. Now let us do next step by step. Now let us move forward step by step. You can see here start FatFS system is printed. Okay. Now reset it and add the breakpoint here and click on play. Okay. This is start FatFS system is printed on serial and SD card has been mounted successfully. Next. You can see SD card total and free size is printed. Next. Here STM_file.txt is created and open in read write and create mode. Okay. Now we are going to write the string hello from STM32 data retain using f_write function. Okay. You can see string has been written successfully. It is 53 bytes. Now file has been closed. To test the read file, we will open it again in read mode. Okay. File has been opened and move the cursor pointer in beginning. Here it will read and store it into read write buffer. You can see here it is printed what we have written earlier, hello from STM32 data writing using f_write function. Okay. Now we will append some string into the file. We will again open the file stm_file.txt in write and open existing mode. Move the file pointer to the end of the file and copy the string appended new data to file into read write buffer. Now write this string and print the message appended new data to file. And now close the file. We will again open the file into read mode to check this append feature. File has been opened and here the file has printed the read write buffer. You can see here the appended string is printed. So friends, this feature is tested. Now close the file and unmount the drive. Now I will connect the SD card into my PC. You will see the file stm_file.txt. You can see here micro SD card is open. Let us open the stm_file.txt file. Here you can see the string hello from STM32 data retain using f_write function is retained and we appended the string later. This line was appended later. Okay. Okay friends, I hope you enjoyed this video. If this video is really helpful, then please do like, subscribe and share. Thanks for watching.